when it goes to sending data back. The front end makes a request. All these things happen. Proxies and routing and more proxies and more routing and forward proxies and things like NGIX. And finally it gets to an application and it gets down to a piece of code. It runs the code and it sends back a result. The example I'm going to use here is with a local server that I run on my system. That's actually the IP address, which you'll notice is a Class C address, so it's a local server that I'm testing with. But it's going to make a request to this thing, API account list, and send back a list of accounts. In this case, it sets a header to say it's sending back JSON data, and I give you an example of, oh, here's the list of accounts that it sent back. So when we go out and do something like, let's go back to our example here with this particular site, and it brings up this pretty thing, and we say something like assemble this piece of code, and we type in some piece of code here. Okay. And we've got, it's not a very good piece of code, but I click assemble. What's actually happening behind the covers is it's taking that code, it's sending it off to the server, it's calling the assembler, it's producing the code, it's producing a listing and a symbol table, and sends all of that data back to the client where it then gets displayed to you. So it's making a round trip to the server to do this. And that round trip, when it comes back, it's in, guess what? JSON format. And that's what you see is the results of taking that JSON format apart and rendering it so that it's human readable. And that's basically how most applications these days work. Now, why did we quit building actual desktop applications? Well, we haven't quit completely, but it turns out that for lots and lots of reasons, the model that was being used for building these didn't match well with how the computers are working today. When we have servers, like here's an example of this ARM-based server with 80 cores per server, and you put 6 of these into a box. There's a pretty normal sized box in a data center. You have more compute power in that box than most entire data centers did 20 years ago in a single box. And this kind of a model for the architecture of the hardware leads to languages like Go and leads to making it easier to build applications like this that are distributed. Also, the distributed data aspect of it means that we can share data with different sources and different locations and make that data work better. So those things tend to indicate that we're going to change the way we build data. And when it was just a document on our own computer and we had one processor, Word and Excel were the big applications. Today, things that communicate are the big applications. In the future, we're going to see more and more applications that have no server involved because they're using a blockchain, or they are talking to something like an IoT device that is a specific device and the front end needs to run so that users can access it. But that front end is built as a web application that talks to a back-end server, and that's kind of the architecture. Now, one of the things that you want to do is you want to be able to find out what the IP address of your computer is, because that's really useful when you go to debug something. And we know about localhost. We can set some stuff up with localhost, but sometimes you need to find out the IP of your computer itself. And I'm going to give you the command line versions of this that you would run. On Windows or Mac, usually you have ifconfig, which stands for interface config. And on a Mac, you are looking for something that says this, inet, some particular address. You'll notice that's the address I used before in my example. But on a Linux system, it would still said inet, but it wouldn't be EN0 up here in the block. It's usually ETH0 or ETH1. But this is the address of your computer. Now, this address changes when you connect to different networks quite often because of DHCP. If you go on a Windows system, instead of ifconfig, you're looking for ipconfig. Again, in PowerShell, you run ipconfig. It's a little bit easier to read. So you're looking for your local machine address in that output from that. And I put in a link right here on how you do this on Windows, and it's got examples. So protocols, other protocols, HTTP 1.0 and 1.01 ruled for 20 years. You'll notice that my browser is still using HTTP 1.1 when it talks to localhost. But there are these other protocols. HTTP 2.0, in the past 5 years, it takes all of the headers, which quite often are larger than the content of a file, and it uses some compression. It allows multiple channels to connect from the front end to the back end, so it produces a 20 to 30% improvement in throughput by better using the communication channel in that fashion. Also, if you have multiple files that you're transferring, most pages when they display, they have the HTML page and a bunch of images and style sheets and JavaScript. It allows the client and the server to stream all of those things together in a single burst of data instead of making separate requests for all of them. So collectively, it's about twice as fast or more for most pages than HTTP 1.1. There is a new protocol out there that is just beginning to be used called Quick. And all of these protocols before this have basically been running on TCP/IP, which is a reliable transfer mechanism, but it has a wide variety of problems that have to be overcome. Let's put it that way. Quick skips the TCP/IP layer and goes down to an unreliable layer called UDP and implements its own reliability system that is more suited to the way we use communication today. TCP/IP has been around for a long time. And Quick, again, produces about a 3x improvement, which is a lot in terms of rendering pages. And it's just beginning to be used. And the library in Go for Quick is still in beta test. I don't know that there is a library yet for making a Quick server in Python. Lots of the big web serving front ends that could take your local request and then turn it into a quick format request like NGINX, Nginx, do not have the capability yet. So it's just beginning to be rolled out to the world, but it's going to make a dramatic impact in terms of how fast pages render.